Hey guys, Zong here, back with another math video. Today we're going to be doing AMC 10. It's a bit of AMC 10 practice considering AMC 10 is coming up. It's AMC 10 season, so this is number 25 from the last test of last year. If you've already done AMC 10, perhaps you've already seen this problem, but it's an interesting problem. And yeah, it's always good to review old problems and get some AMC 10 practice. So look at the problem, pause the video if you need to. It's a probability problem, so. Okay, the solution. So, the 11 lily pads labeled in a row 0 through 10. Frog is sitting on pad 1, and the frog is on pad n. 0 is less than n is less. Yeah, okay. So, how do we go about this? Usually, when you face these types of probability problems, with like probability going forward is this, probability going backwards is this, you usually want to make a flowchart, but oh whoops, not on the brush. The heck, sorry. You usually want to do something like this, probability going in this position, probability going in this position, and then you do some math like this. It's good to visualize the problem like this. But we have 11 lily pads, so it's going to be harder than that. But we have to notice a pattern. We have to notice that on pad 5, yes, on pad 5, the probability of going to pad 0 and the probability of going to pad 10 is equal. So on pad 5, the probability of reaching pad 0 from pad 5 and the probability of reaching pad 10 from pad 5 is equal. It's a chance of 1/2. If you think about this, probability going backwards is 5/10, probability going forward is 5/10. And from then on, the probability of reaching their respective pads for 0 and 10 are the same. Conditions are same, except they're just reflected across pad 5. So we can make a flowchart. Essentially, we can make a flowchart of just 5 pads because we know the probability from 5 to reach 10 is when you are on 5, the probability to reach 10 is 1/2. So what's the probability of reaching 5? I mean, what's the okay, so we want to know the probability of getting pad 10 from pad 1. So we're gonna have the probability represent Pn. That number is the probability of getting to pad 10 from lily pad n. So you might as well make a flowchart. So here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's take a look at this. So we don't want to consider the probability if 1 goes over here, because that's just 1/10. We don't want. That's like, what's the probability of me descending to hell? Well, I don't want to know. We're just gonna. This is 9/10. And going back from 2, that's 1/5. Just some calculations based on the problem. Going forward is 4/5. And then I believe going backwards is 3/10. Going forward is 7/10. And going backwards is 2/5. Going forward is 3/5. And going backwards is 1/2. So we have this flowchart right here. It's very nice. So what's the probability of reaching? So P1. What's the probability of reaching pad 10 from P1? We know. This is what we're given. Okay, I should really change it. This is what we're given. P5 equals 1/2. And from here we can just move our way back to 1. So what would P4 equal? Well, P4 equals so let's say it's 2. Let's say the chance of it going back to 3. The chance of it going back to 3 is 2/5. But then from 3 to get to lily pad number 10, that would just be times P3. Now we consider the probability that 4 moves forward on a chance of 3/5 times P5. And again, this might get a bit confusing. Multiplying probabilities, what is this? It really confused me the first time I did it, but basically we're saying that on the chance that it moves back with 2/5, the chance it's just the probability of getting to pad 10 is now pad 3. Probability of reaching it from pad 3. Because if you go 2/5, then you're on pad 3, and then probability is just P3, because that's probability of moving to 10 from pad 3. And then 3/5 is just times P5. And you can actually cross out P5, and that's just 1/2. So P4 equals 2/5 times pad 3 plus 3/10. Okay, we have P4. So now we want to know P3 because we need P3 to find P4, right? Well, sort of the other way around. We can actually do this. We actually do this. So okay, never mind. Let's just move on. So so P3 is the probability of doing a similar thing, 3/10 times n2 plus 7/10 times n4. Oh frick, I wrote n. P, sorry. And then of course P2 equals 1/5 times n1 plus 4/5 times n3. And then n1, which is what we want to find, equals 9/10 times n2. Alright, so let's take a look at this. So, okay, I'll just cross this out because that was similar. So we have 1, 2, 3, 4 equations. We have 4 equations, and we have 4 variables. So, what this tells you is we can find... Frick, I said n again. I'm not, sorry. We can find P1 through 4. Because we have 4 equations and 4, why do I keep saying n? I don't know why. We have 4 equations and 4 variables. So, using the system equations, we can just find P1 through P4. And after bashing out a bunch of algebra, which I know you guys are capable of doing, we get that P1 equals 63 or 146. That's what you get from solving these 4 equations, which I should probably do for you, but running short on time, so that is the answer. It is C. Hey guys, Zong here, back with another math video. Today we're going to be conquering cryptorhythms, and I'll spell that out. Cryptorhythms. Yeah. You may be wondering, what is a cryptorhythm? And you can just look at the problem, and you can probably just tell it's those things that you see on math competitions